value of x in state if it's a Pythagorean triple. So on the first 6 problems, we're going to be using the Pythagorean theorem. A squared plus b squared is equal to c squared. And the Pythagorean theorem only works if the triangle is a right triangle. If it's a right triangle, then this will be true. And again, so Pythagorean's theorem here, a squared plus b squared equals c squared, only works if it's a right triangle. And realistically, if it's a right triangle, then a squared plus b squared equals c squared will hold true. And the main point, or part that we need to make sure we have correct, is that c is always the hypotenuse. C is always going to be the hypotenuse. The values for a and b are going to be the other two sides. So when we look at this here, 3 and 4 are going to be the other two sides because x is opposite the 90 degrees. The side that's opposite the 90 degrees is automatically the hypotenuse. So we can plug these into the Pythagorean theorem to solve for the hypotenuse. So we'd have 3 squared plus 4 squared is equal to c squared, yes. So 3 squared plus 4 squared, as long as it doesn't scroll, would give us 25 is equal to c squared. So it's telling us that the side length c times itself gives us 25. So we have to take the square root of both sides, which tells us c, the hypotenuse would be 5. Now the next part of the question that it asked was not just to find c or find x, the missing side, but also determine if it's a Pythagorean triple. And here it would be yes, because it is a Pythagorean triple if all 3 sides are natural numbers. The theorem states that it's integers, but those are about the same, especially since side lengths can't be negative. That's one of the main differences between integers and natural numbers. So if one of the side lengths has a decimal, then we know it's not going to be a Pythagorean triple. Yes, sir.
So on here it says, or okay, on here I'll put yes because do I put yes because it's isn't? Or
Well, it doesn't actually, it just says state if it's a Pythagorean triple. Well, yes, it is. So it's not asking for explanation, it's just saying it's whole number, yes. Yes. Good question. Now let's look at the next one here. So here we're still using a squared plus b squared equals c squared. And again, it wants us to find the hypotenuse because x is opposite the right angle. So we can plug 10 in for a and 13 in for is equal to c squared. We could call it x squared because the hypotenuse is defined as x right now. So we could call it x or c. Now at this point here, again, since 10 squared and 13 squared are both on the same side, we can plug them in. Or if we did it by hand, 10 squared is going to be 100. 13 squared is 169. 269. And again, we need to take the square root of both sides, which tells us c is square root of 269. I think it gives us right back. Oh, apparently it wants to scroll. Square root of 269 would be the correct answer. Now, guys, is this going to be Pythagorean triple? No. Because the square root of 269 is not a whole number. It's not a natural number.
I have a question.
Yes.
Okay.
Guys. All right, let's look at these here. These two here are different because they give us the hypotenuse this time, and we're solving for one of the other sides. So we're still using our a squared plus b squared is equal to c squared for this here. Now, for this first one here, they told us 25 is the hypotenuse because it's the side opposite the right angle. Well, I plug 24 in for A or B. We plug 24 in for A or B. Either one. Because if I add two things together, it's still going to be the same, isn't it? So one of them we can say is A squared plus 24 squared. Now, unfortunately for this one here, we can't just type 24 squared plus 25 squared into the calculator because they're not on the same side. So we can solve for each one individually. So if we try to find 24 squared, we can type it into the calculator and get 576. 25 squared is... Now, we need to get a squared by itself first before we can take the square root. Minus 576 from both sides. Which will tell us a squared is 49, yes. Take the square root of both sides. A is 7. So is this a Pythagorean triple? Yes. 7, 24, 25 is a Pythagorean triple. And some of those are nice to know. Any questions on this one here?
No, I did have trouble on number 5.
Okay. Let's look at number 5. So again, we're still using Pythagorean theorem. A squared plus b squared equals c squared. And when we look at this here, which are we trying to find? Are we trying to find the value of a, b, or c? C. So we can say c is our x squared, or we can leave it as c squared. It really doesn't matter. It's just a variable that we're solving for. And the values of a and b are 4 and 2. So we'll say 4 squared plus 2 squared gives us x squared. Now, since 4 squared plus 2 squared, our two numbers are on the same side, we could type all that into the calculator, and it would give us an answer, 20, is equal to x squared. And at this point here, we can square root both sides. The square root of x squared is x. And the square root of 20, if you typed it in, will give us 2 square root of 5. So this would be exactly no. Because 2 square root of 5 is not a whole or natural number. Any other questions on 1 through 6? So it'd be good to have the Pythagorean theorem there. Now, I did post this to everything that's on the whiteboard to Google Classroom. I posted it this morning. You can put all of that down somewhere in the note sheet. That's fine. I think a better suggestion would be to put it down where it occurs. Yes, sir.
So how would you know when to use that?
So here, because Pythagorean theorem works on any right triangle. And here, it has 1, 2, 3 variables, yes? And they're all side lengths. Well, how many variables do I need to be able to solve for? Well, if I have 3 variables, I can only solve for at most 1. So if I have 2 sides, doesn't matter which 2, I can use this theorem to solve for the other. I need at least 2. So if I have 2 sides of a right triangle, I can solve for the third. So any other questions on this here? Determine if the following triangles are right triangles. Well, try this again. A squared plus B squared equals C squared. This theorem only works if it is a right triangle. Because if it's a right triangle, then A squared plus B squared equals C squared is true. If the three sides plugged into this formula do make a true statement, then it must be a right triangle. Yes.
And the right angle is always opposite. You say that the angle between 20 and 21 is right angle.
If it is a right triangle. Because not all the figures are going to be drawn to scale. So here, if number 7 is a right triangle, then the right angle would be between the side lengths of 20 and 21. They would form the right angle. And for any triangle, the hypotenuse is always going to be the biggest side. For a right triangle, the hypotenuse is the biggest side. So for this one here, our hypotenuse would be 29. It would be C squared, which makes 20 and 21 A and B. So if this is a right triangle, then 20 squared plus 21 squared should equal 29 squared. And 20 squared plus 21 squared, well, 841, because we can type this into the calculator. And if we type 29 squared in, we get, so this would be, because here it's just asking, is it a right triangle? Yes. Now if we look at number 8, the hypotenuse is 62 squared. And this should equal 11 squared plus 3,007. So these here are, no, it's not a right triangle because A squared plus B squared did not equal C squared. It didn't ask it for this problem, but what kind of triangle do we actually have? Guess which one's bigger? The hypotenuse has the bigger number, so it's obtuse. Yep. So, any other questions on 7 or 8? How about number 9?
Oh, number 9. 25 is a hypotenuse.
This is yes.
How can you tell?
7, 24, 25 is a Pythagorean triple. That's just knowing that one. Also, number 3, we found x as 7, 24, 25. Worked. And some of them, knowing the Pythagorean triples is helpful. 3, 4, 5 is a Pythagorean triple in any iteration of it. So 3, 4, 5 works. 6, 8, 10 works. 12, so here 12, 3, 4, 9, 12, 15 is a Pythagorean triple. Any multiple of those 3 going up are Pythagorean triples. So if I remembered, 7, 24, 25 is a Pythagorean triple, okay, so it is a right triangle. Now the way we can check it exactly, Logan, would be 7 squared plus 24 squared is equal to, and I believe they're actually both 625, so it is a right triangle. And especially on the ACT, when stuff like this comes up, knowing the Pythagorean triples is helpful because you can do problems a lot faster, especially if they give you, Timmy walked 16 miles north and 12 miles east. Okay, well, it's just going to be, because 16 is 4 times 4, so 5 times 4 would give us 20. So knowing them is sometimes helpful. Any other questions on 10 or 11 with these Pythagorean or right triangles? Okay. Now this 12 through 17, Need to go back?
So number 11.
Yes.
How?
So the biggest angle is opposite the biggest side. So for us, the hypotenuse would be 17. Yep. Let's go on and finish this out because I know 8 squared is 64. I think 15 is 225.
Yeah.
So 64 and 225. 289. You'll have to help me with 17 squared.
Come on, I know you know it.
What?
Oh, 17 squared is 289.
So this did work out, yes?
Whoa.
Okay. Yeah. Making there, 15 squared. Okay. Yeah. Okay. So looking at these three here, we'll look at these three next. We're not just looking to determine if it is right or not. We want to see what kind of triangle we have, acute, right, or obtuse. So we'll look at the first one here. Now again, the biggest side is always going to be the hypotenuse. And it's always good to actually look and make sure which one is the biggest side and not assume that they are in numerical order. So here, 109 is going to be the hypotenuse. So we want to see how does 109 squared compare to 60 squared plus 91 squared. And we can type these into a calculator to get the answer. So if we did 109 squared, what would we get? 11881. And for 60 squared plus 91 squared, we get the same thing, 11,881. And since they are the same, this means it's a right triangle. Because it's right if a squared plus b squared equals c squared. This is a right triangle if a squared plus b squared equals c squared. Now let's look at the next one. Well, this time the hypotenuse is 9. So we want to see how 7 squared plus 8 squared connects to 9 squared. Well, 9 squared is 81. Now 7 squared plus 8 squared is 113. Well, this time they're not equal. But a squared plus b squared is greater than c squared, which means it's acute. Because when a squared plus b squared is greater than c squared, it's going to be an acute triangle. Yes. And that brings us to this next one here. So 15 squared plus 112 squared, and compared to 140 squared. 169, and the other one, 7. 19,600. Okay, well, this is definitely telling us that c squared is bigger, which means it's obtuse. Because if c squared is greater than a squared plus b squared, it's obtuse. If a squared plus b squared is greater than c squared, it is acute. And if they're equal, then it is right. And that's it. That's all we're having to do for these here. Any other questions on these here? Any other questions on 15, 16, or 17? Because these here are similar type. So I would make sure, especially in this area, to have the comparison for a squared, b squared, and c squared, how they relate to acute, right, and obtuse. Yes. Okay. The next part that we have is special right triangles. So our 45, 45, 90, and the 30, 60, 90. So when we look at 18, this one here, we know that this is a 45, 45, 90 right triangle, mainly because we have two 45-degree angles. Because it only wrote one down, but we know because the sum of the interior angles has to be 180, and one of the angles is 45 and the other is 90, the other one has to be 45. And we know the sides opposite the 45 degrees are going to be the same. So it tells us that x has to be 7, well, stop scrolling, 7 square root of 3. And by the tricks that we had, the shortcuts to find the hypotenuse, we can take that value and multiply it by the square root of 2, which will tell us that y is 7 square root of 6. Okay. Oh, yeah. Where's all that? Well, since we did those, because we did those towards the start, like the second section in, yes? What we used recently is sine, cosine, and tangent, yes? Because if I have an angle on one of the sides, I can use sine, cosine, and tangent to solve for the missing sides. So if I took, say, I wanted to find x, so tangent of 45 degrees. And tangent is equal to opposite over adjacent, yes? Well, so I can pick this angle, and the opposite side would be x, and the adjacent would be 7 square root of 3. Well, the next thing I can do in solving for this is to multiply both sides by the denominator, 7 square root of 3. Well, here they would cancel, telling me that 7 square root of 3 times tangent of 45 degrees is equal to x. And at this point here, we can type in 7 square root of 3 times tangent of 45. And when you type the square root in, you need to make sure you use the arrow to get out of the square root. Because otherwise, it'll be 7 square root of 3 times tangent of 45. It'll give you, in this case, it won't make a difference, but in most it will. And if we type this in, we actually get 7 square root of 3. Okay. Well, apparently it's going to keep scrolling. No idea. Any questions on this so far? Now, I do have two sides of a right triangle, yes? We could, but we couldn't use sine. Or we couldn't use tangent, because tangent is opposite over adjacent. So I would need to use sine or cosine. So we can say sine. We can't use 90, but we would use is equal to opposite over adjacent. Or opposite over hypotenuse, sorry. Well, the opposite side would be 7 square root of 3, and the hypotenuse is y. Now, it really doesn't matter which angle we use, because both of the sides opposite them are 7 square root of 3. We times both sides by y, yes, which will tell us that y sine of 45 is equal to 7 square root of 3. And then what do we do next? By sine of 45, yes. Which these would cancel. Minus y is equal to 7 square root of 3 over sine of 45. Seven square root of 6. Yeah. Because the reason, and again, for next year, I don't know why I haven't thought of doing this before. We're going to do sine, cosine, tangent first. Because this here is why the shortcut works. Because we can actually solve it using sine, cosine, tangent. And it just so happens to work out that the sides opposite the 45 degrees are the same. And the hypotenuse is just whatever that value is times square root of 2. And it works out that way every single time. But it also works out that I could use sine, cosine, and tangent and solve for them. Or realistically, once I'd gotten the other side, or that I knew that the sides opposite the 45 degrees were the same, and I got the second 7 square root of 3, well, we could have said 7 square root of 3 squared plus 7 square root of 3 squared is equal to the hypotenuse squared. I can use the Pythagorean theorem once I get one side. Because the Pythagorean theorem works on any right triangle, and I have two sides. And 7 square root of 3, so that would be 49 times 3. 7 to 149 plus 149 equals c squared. Okay. Yep. 8. Thank you. 47. 4. So 249. And if we square root both of these, we'll see that c is 7 square root of 6. So there are multiple ways to get there. We don't have to just stick with the shortcuts. And that's helpful, especially if you get to the test, and this part on the test, and you forget how to do the shortcuts. The sine, cosine, tangent will work. So if we look at 19, it's another 45, 45, 90. And the sides opposite the 45 degrees are going to be the same. Well, they didn't give us one of those because the two sides opposite the 45 degrees are x and y. But we do know whatever the value of x is going to be the same as the value of y. Yes, so the shortcut that we found is taking the hypotenuse and dividing it by the square root of 2, which turns out to be 6. So it tells us both of these sides are 6. Because we could have used sine of 45, and we'll use this angle here, would be y over 6 square root of 2. And at this point here, we can multiply both sides by 6 square root of 2, telling us y is equal to 6 square root of 2 times sine of 45. Well, tell us that it's 6. And we could have also used Pythagorean theorem because, again, we need to know 3 side lengths, yes? But I know that the 2 that are missing are the same. So even though that they're the same, 2 missing, but they're the same, I can say x squared plus x squared is equal to 6 square root of 2. Because even though we're missing 2 side lengths since they're the same value, it's not that big of an issue. Because here we would have 2x squared equals 6 square root of 2. Divide both sides by 2, and we'll get that x squared. X squared is equal to 3 square root of 2. I did that right? Yep. that's why. Trying to get going way too fast. Does anybody see where the mistake came? I forgot to square the c. So it should be that 2x squared is equal to 3672. And if we divide both sides by 2, we get that x squared is equal to 36, and we square both sides. It tells us x is 6. So the two sides would be 6. So if on these here we remember the Pythagorean, or not the Pythagorean theorem, but the shortcuts, and we get those, it makes these here a lot easier to solve and a lot faster. We can do them quicker. Or we can use the Pythagorean theorem after we find one of the sides to find the rest. Or we can use sine, cosine, and tangent to find one. So here, this next one, we do have a 30, 60, 90 right triangle. Well, they gave us the side opposite 30, so by the shortcut, the hypotenuse is 2 times whatever that value is, which tells us that it would be 10. The side opposite 60 is the short side times the square root of 3. So it's 5 square root of 3. And that's it. So if we recognize the shortcut, we can get right there. If not, what we can do is look at this here and use sine, cosine, or tangent. Doesn't matter which. So we could use tangent of 60 degrees. Because tangent is opposite over adjacent. And the opposite side to 60 degrees is x, and the adjacent side is 5. So we can multiply both sides by 5, telling us x is equal to 5 times tangent of 60. And guess what x is going to be? 5. Now we could use sine or cosine to find the hypotenuse. Or we could use the Pythagorean theorem and say that 5 squared plus 5 square root of 3 squared is equal to our y squared. Well, 5 squared is 25. 5 squared of 3 squared is 75. And 25 plus 75 is 100. Square root of 100 is 10. So we get the hypotenuse is 10, and the side opposite 60 is 5 squared of 3. So the shortcuts do work, and they're a little bit faster, but sine, cosine, and tangent, once we get one side, we can use the Pythagorean theorem to find the last one, works as well. Yeah. And the 3 of them are based on what is given. Because if we're given the short side, we take it and multiply it by 2 to get the hypotenuse. So 5 times 2 gave us 10. Multiply it by the square root of 3 to get the long leg, which is our 5 square root of 3. So 21 is one of our 45, 45, 90s, because we do have a 90 degree and a 45 degree angle. So we know that the value of x and y are going to be the same, because 4 is opposite to 90. The side opposite 90 is the hypotenuse. So the shortcut tells me that I need to take the hypotenuse and divide it by square root of 2. If we type this into the calculator, we'll get 2 square root of 2. So the shortcut tells me that both of these are 2 square root of 2. And we could have done the same thing with the Pythagorean theorem, setting it as x squared plus x squared is equal to 4 squared and solving that way. Or we could have used sine and cosine. Because sine of 45 is equal to opposite over the hypotenuse. And we multiply both sides by 4, which tells us y is equal to 4 sine of 45. And 4 times sine of 45 is 2 square root of 2. Then if we wanted to, we could have used tangent to find the other side and get it that way. There. Any questions on any of this here? I want to do one more thing first. Can anybody tell me what tangent of 45 degrees is? 1. Tangent of 45 is 1. And this here, 45, yes? Because this is 2 square root of 2. This is 2 square root of 2. And tangent, you don't have to write any of this down, of an angle is opposite over adjacent, yes? So for this triangle here, on either 45, so we'll say this angle here, the opposite side is what? 2 square root of 2, yes? The adjacent side is what? Well, 2 square root of 2 divided by 2 square root of 2 is? Tangent of 45 degrees is 1. And that's where we'll stop